Okay, just to get you thinking a little bit, because we need to do a little bit of simplifying in some of these questions, not all of them. I want you to think back to all that work we did around radicals and how we simplified those. So I don't know if you remember this, but some of you didn't do it too long ago. Some of others did it a long time ago. What we did is we kept breaking these down into its prime factors. Okay, and then we listed the factors. 2 times 2 times 3. And remember how the index is the check part of the radical? Well, this is 2. So I'm going to circle groups of 2. They can come out, so I'm going to put a 2 outside. I've got to leave the square root of 3 inside. So that's how the square root of 12 can be rewritten. So how about 50? How can we simplify that? Well, let's stop the video and try it if you want. I'll just keep going and do it. So 50 is even, so I'm going to divide it by 2. And then 25 is 5 times 5. So I've got 5 times 5 times 2, and the index is 2, so I can circle a group of 5. So square root of 50 is the same as 5 square roots of 2. Keep this stuff in mind as we do this rest of this work. So now we're moving on beyond algebra tiles when we do this. And we're going to follow a process, but what we learned when we did algebra tiles will come right along with us. So the first thing we have to do is we have to move the constant term to the other side of the equation. So that will become 2x squared minus 16x equals negative 20. And I'm sorry, that equal sign shouldn't be there. Well, it can stay there. I'll try to squeeze it in. Then the next thing we've got to do is we've got to, if a, remember these are ax squared plus bx plus c. If the a, the number in front of the x squared, is anything except 1, we got to try to factor it out. Now, this can get messy. Fortunately, all the ones I'm going to have you do are not too bad. Algebra 2, they'll be a little more tricky. But it's just fraction work, it's not impossible. So, but for this case, I'm going to factor out a 2 and 2x squared. So what I'm doing is I'm saying 2x squared minus 16x. I'm dividing both of those by 2 to factor it out, right? So 2, then I'll have an x squared, and I'll have a minus 8x left inside. And I'm not going to do that with the other side. I'm just going to leave it alone. So now, so you remember back in that last video how we learned that we took half of the number of x, like if there were 6 x tiles, we took half of it and squared it, and we add that to both sides. That's where we're going with this. So the b, our new b number is negative 8. I'm going to take half of that negative b and write it here. And of course, if you think back to all that work we did with the box method around multiplying or factoring quadratics, I remembered I'd have to have next, because those two have to add up. Right? These two terms have to add up to negative 8x. And then we're going to take that half of that term and square it. So half of negative 8 is negative 4. If we square it, we get 16. Then we ask ourselves, what's the greatest common factor between negative 4x and 16? Well, I can factor out a negative 4. And I can do the same thing here. That'll always happen. That's completing the square. And then what do? We're going to take our c term, that's 16, and we're going to multiply it by the a term, which is 2 in this case. And that'll give me 32. And then I have to add that. That's what I'm going to add to both sides of this equation. That 2 is what causes this. All those examples I did before, we just had the a number was 1, so we didn't have to worry about that. This is a template. This is a pattern that'll always have to do that. And then what is our original c term? Our original c term was negative 20. What's 32 plus negative 20? That's equal to 12. So now we're going to write this in, so these are our tile dimensions, right? And that's what's on the other side of the equal sign. So x minus 4 squared has to equal 12. We'll take the square root of both sides. So x minus 4 equals the square root of 12, and x minus 4 equals the negative square root of 12. And if you remember that problem I just did on the warm-up, we knew that The square root of 12 became 2 square roots of 2 square roots of 3, right? Because remember, this was 2 times 2 times 3, and we can group the 2. So we're going to get x minus 4 equals 2 square roots of 3, and x minus 4 equals negative 2 square roots of 3. And we'll just add 4 to both sides. And we'll get this messy answer, which isn't that messy. It's just who really wants to check that? We know it's a decimal, some decimal value. So that's my 2 solutions, and I completed the square to do it. Okay, so another question here. So again, I got to move the C. What's different about this one, though, is the 17's over here instead of 0. But that's okay. We're just going to add 19 to both sides. So that's going to give me 4x squared minus 16x equals 36. On the left-hand side, I'm going to factor out that a, so that leaves me x squared minus 8x. Remember, I'm dividing both of these by 4 to do the factoring. That's equal to 36. And then, let's see, what's my b term? My b is negative 8. So I'm going to take half of that, add that, or half of that, which is negative 4. Let's see here. Negative 4x, negative 4x, and then we're going to square the negative 4, get 16, and then, of course, like we did with the factoring, we get negative 4 and negative 4. We've got then the twist here with the a term. So 16 times 4 is 64, and I had the 36 originally. So if I add those together, I think I get 100. So what do I do from here? Well, I want to write these in that perfect square form, that not the x minus 4 times x minus 4, but write it as x minus 4 squared. And that has to, and then I need the 4 out in front, and that has to equal 100. Now to solve this, we're going to inverse our operations. Divide by 4 to get that 4 minus x squared by itself. Then I'm going to take the square root of both sides, and that leaves me x minus 4 equals negative 5, and x minus 4 equals positive 5. I see I probably could have factored this and not had to do this work. So I'll add 4, I get negative 1. I'll add 4, I'll get 9. So those are the 2 solutions for this quadratic equation. And it's that easy. Yeah, we'll give you some practice to go do. I'll give you a worksheet with some paper ones to do, and then we'll do some my open math kind of questions. And the last thing I have here is I have a template here, and this is enough for 2. This is enough for 2 problems, and you'll want to, if you need to print them, you can. If you don't have a printer, you can kind of write it out by hand. You don't have to do quite the same detail because writing that out would be a pain. But it's the process isn't too bad.